Hi, welcome to today's Edpuzzle, where we're going to talk a little bit about factoring quadratic equations from standard form using generic rectangles. So, just to get us started, let's see what we remember about quadratic equations. Pick something from my Edpuzzle list here that all quadratic equations have in common. Hopefully you said that x squared component, because that is usually the tip that tells us what all quadratic equations have in common, no matter what form they're in. So I put up here the three forms. Standard form, you can see, sure enough, in standard form, there's my x squared component right there. In factored form, which is what we're going to get to from standard form today, it's a little harder to see the x squared term, but if you have two x's being multiplied together, they should end up with an x squared term. And then in vertex form, sometimes called the graphing form, you can see there's an x inside these parentheses, and that's squared out there. So somewhere, once we multiply it out, we're going to end up with an x squared term. And each three of these forms are all ways we can express quadratics, and they all have their own unique qualities and benefits. But we're going to focus today on going from standard to factored form. And we're going to use a procedure called a generic rectangle to help us do that. So I'm going to get us started to do one. See if I can get this to line up, and then I'm going to have you help me try one. So let's try factoring a quadratic equation that looks like this. Let's do 3x squared plus 11x plus 6. If this is our quadratic, let's figure out how we would factor it to figure out its sides. So we use this idea of the generic rectangle. You might have watched the video where we talked about how to go from factored form into standard using this. So now we're going to go backwards. So the idea is that there's an area inside each of these boxes. In this case, in the top box, we're going to put the first coefficient of that ax squared coefficient. That's going to go in this top box here. So we're going to put 3x squared. So the area of this box is 3x squared. And we're going to put in the bottom box the c term, which in our case is 6. We know then that the other two rectangles, this diagonal here, have to add up to give us our bx term if we're in standard form. So we know when we add them, they have to give us 11x. And then we're going to use this idea of a diamond. You might have done this in the Algebra 1 book if you've done any problems out of there, but it's kind of like a puzzle problem where it says, hey, whatever's in the top of my diamond, in this case, we're going to take the diagonal of what happens when we multiply 3x squared times 6, so 18x squared. So we're going to put that at the top of our diamond. Whatever's there has to add up down here. So let me say this a different way. Whatever I put on my sides, when I multiply them together, I have to get 18x. But when I add my two sides together, I have to get to the bottom, which is 11x. So let's figure out what are some numbers that multiply to give us 18x squared. And if we start with that, then we can figure out which of those that multiply to give us 18x squared will add up to give us 11x. So we have to find some factors of 18x squared. So you tell me, what are some factors of 18x squared? Okay, maybe you said one of them was 1x and 18x. Because 1 times itself will always return that number. And notice how we're splitting our x's out. So what are some other ones? You might say 3x. If I multiply that by 6x, then we might say 2x and 9x. So now our job is to figure out if these are all factors that multiply to give us 18x squared, which of them will add to give us 11x? It looks like 2x and 9x. So those are the other two areas that we can use in our problem. So I'm going to put the 2x here and the 9x down here. And now we know what we have to have each of our side lengths multiply to give us. So we're going to take a look at this and say, okay, I know that the area of this has to multiply out to 3x squared. So what's my length and width that gets me there? And I can do that by kind of looking at my factors. So for this column right here. My greatest common factor is 3x. If I multiply on 3x on the top, my side then has to be x, because x times 3x gives me 3x squared. Let's take a look at then the greatest common factor here of 2x in this column and 6. Oh, that looks like it's going to be just 2. Because they don't share an x, but you could multiply 2 times 3 to get you 6. So if I do that, if I know it's 2 times 3, then that means this better be 3. And I can check my other one and say 3 times 3x is 9x. Yep, that one works. So I know now that the sides of my rectangle that give me the area of everything inside is 3x plus 2. And if I multiply that by the length of my other side, which is x plus 3, I will get back what's inside there. And this is my factored form that is equivalent to my standard form up here for my quadratic. So now that we've done that together, I'm going to let you take the lead on one. Let's try another one. And we'll even add some challenge to this one. We're going to say 4x squared plus 22x plus 10. So now it's your turn to take the lead. What's going to go in my first top box right here? I'm hoping you said 4x squared. If you did, then I know you're listening. What will go in my bottom box? I'm guessing you said 10. When I multiply those out, what do they have to what will they multiply to? You say 40x squared. And then what do they have to add to? Down here in the bottom of my triangle. Diamond. Okay, hopefully you said 22. So let's look at some factors when I multiply my two side terms. I got to get to 40. When I add my two side terms, I got to get to 22. So let's start with what are some things that multiply to give me 40x squared. So you might have said 1x and 40x, 2x and 20x. Let's see, what are some more? 4x and 10x. 5x and 8x. There's a lot of factors. Which of these factors then, when I add them up, will get me to 22x? I'm hoping you picked this one, 2x and 20x. Let's go ahead and drop those then as the areas of my other two generic rectangles. Doesn't matter which ones I put, but it is going to matter when I do my factoring. So let's take a look at this column here. What factor do I want to pull out there? You might have said that you want to pull out 4x, and that would certainly work. So if I pull the 4x out here, what am I going to have to multiply that over on this side to make sure it gets me the area of 4x squared? Hopefully you said 1x or x. And if I do that, then let's work and keep going. If I have x here, what am I going to have to multiply the top by to get me 2x? 2. And then let's take a look. This is where it's a little trickier too. So if I got a 4x here and a 20x here, what do I have to multiply 4x by to get to 20x? I should say 5. And let's double check. 5 times 2 is definitely 10, so we know we're right. So the side length then becomes what? You should say 4x plus 2 and x plus 5. So now that you've tried this, you now know that the standard form here factors to this. You have some tries to do this again, hopefully soon. Do some more practice. Good luck.